Every crystal you know repeats itself in space. Salt, diamond, snowflakes, atoms locking into a pattern that looks the same as you step from place to place. In 2012, a physicist asked a stranger question: could something repeat itself in time instead? A pattern that ticks on a perfect rhythm, forever, all on its own. The reason it sounds absurd is thermodynamics. Anything that moves in a steady cycle should eventually run down. Friction, heat, entropy always win. A thing that ticks forever with no energy input sounds exactly like a perpetual motion machine, the one invention physics says is impossible. But the time crystal sidesteps that trap with a clever loophole. You do poke it, you hit it with a repeating pulse, like tapping a drum on the beat. The shock is what makes a time crystal so strange. You tap it at one rhythm and it answers back at a slower one. That is the tell. Tap, tap, tap on every beat, but the system only flips its state on every second beat. It has chosen its own rhythm, one that is not the rhythm you are forcing on it. The pattern is coming from inside the matter, not from your hand. Physicists call that breaking time translation symmetry. And here is why it is not perpetual motion. A time crystal does no work. You can't tap into that ticking to run a motor or light a bulb. The moment you try to pull energy out, the pattern dies. It just holds its rhythm in its lowest energy state, absorbing nothing on average. Motion without progress, oscillation without cost. The hard part was keeping the beat from smearing out. Normally, a room full of jostling atoms would blur any delicate rhythm into noise within an instant. The fix came from disorder itself, a phenomenon called many-body localization, where the particles get so tangled and pinned that they refuse to share their energy and wash the pattern away. In 2021, a Google team made one for real, using the qubits inside their quantum computer as the ticking spins, dozens of them holding a stable, self-chosen rhythm that a computer could actually read out. Harvard and others did it in other systems the same year. A phase of matter that had only ever lived in equations was suddenly sitting on a chip. So a time crystal is not a battery and not a perpetual motion machine. It is something rarer, a brand new phase of matter, the first one that lives in time. And because its rhythm is so stubbornly stable, it may become one of the steadiest clocks and most robust memories we can build for quantum machines, order that refuses to fall apart.